geoinformaticians, or geoexperts, geospatialists. Uh, this morning I will be explaining how we can go ahead with Professor Ojigi's assignment, and I'll be glad they will all listen and understand what I'm trying to pass across. So I believe we've all downloaded the data. So the first thing you do in this case is I'm trying to search for the question for lay. Okay. Now the professor Baba sent the gravity data southwest region to us in form of Excel SX, that is a Excel format, and the assignment goes like this. We are to perform a spatial gravity mapping and analysis based on the given data. Then this set of gravity data PID of 302 stations over the southwest of Nigeria and their corresponding heights, free air boga anomalies. Good. We have 302 stations or points over the southwest, and with respect to their elevations, the free air, it has been corrected, the gravity has been corrected, the free air has been corrected, we have the value, and the boga anomalies, it has been corrected now. And we have the ordinary gravity value itself. Did you get my point? The gravity value itself, we have it. So the first thing we have to do is what? Map and interpret your data, spatial analysis, your modeling, and transect analysis. Mapping, we are all familiar with mapping. We just pinpoint all those points spatially distributed within the southwest. We had the shapefile of Nigeria. I'm going to show you how we go about that. I'm just trying to explain what we're going to do now. So the spatial analysis, that is what analysis are we trying to do? Are we trying to perform which states is likely to have the highest gravity, the highest height, and stuff like that? I don't know what I get my point. So we are going to get we're going to perform many analyses. We have hotspot analysis just to see how clumsy those data are, and then with that it will give us how cold or how hot the confidence interval of what we're trying to do, which is gravity. And then the modeling is in 3D. You get my point? So we're all familiar with all these things, just that I don't know what is convincing us that we don't understand it. But and then the transect is just like we are going to define a line of our choice. Anybody can use any line of his choice. Now the transect, in the sense that when you talk about transect, it means a line passing through a region and maybe perpendicular or whatever line, just to see maybe at irregular interval, maybe you have a line, maybe curved line, straight line, any form of a line, and then running through maybe Lagos to Ekiti. Now at so interval, we're going to interpolate the gravity value, both the heights, we're going to interpolate the heights, we're going to interpolate the gravity itself, we're going to interpolate the air boga, and we're going to interpolate the free air and the boga. Did you get my point? So I'm going to show you everything right now. So that's what I'm trying to do. I'm just trying to explain what we have to do first. So the modeling is a 3D part, and the transect is the interpolation. We're going to interpolate on a particular straight line. Oh, I'm sorry, I've not eaten this morning. So with respect to that line, we can now plot a graph that, okay, this graph is showing us the line is running through Ekiti to maybe Lagos, and then you can see the graph maybe at Lagos State. What is the what is the gravity value. You just, you are plotting x and y, so you have the gravity on the left, the either the state or the distances on the x-axis, your gravity on the y-axis. So you're gonna plot that in form of a graph. So you're gonna see the anomaly across the states altogether. So it depends on how you want to dramatize your map. You get my point? Some people can pick just an arbitrary line in maybe Ocean State. They will just draw the line and see what is the gravity trend, or what is the behavior of that gravity in Ocean State. Some people can take across the entire southwest, maybe a point in Lagos, a point in. Did you get my point? So you just take it that way, and then you plot a graph. At so Lagos we have this height. At so we have this height. At so we have this height. At so Boga we have this value at this particular state on that same point. Did you get my point? So it's just like you're trying to interpolate. So that's why you understand. It will be transit altogether. So now let's go to so okay, I think the instruction one has been done based on the little voice notes I sent. Now you have to write a report on the software platform and the procedure adopted or used. Now the report here is that you have to report the software used. Some people can decide to use QGIS, some people can decide to use ArcMap. So depending on, some people can decide to use MATLAB, depending on whatever you want to use. Did you get my point? But I prefer ArcMap, so I'm going to use ArcMap for this tutorial, for this exercise. So, and the procedure, how did you do it? Okay, what was the first thing? I adopted ArcMap 10 points whatever for this analysis starts. Now the first thing I did was, from the data you gave, I converted the XLX to CSV to recognize my ArcMap environment containing the field appropriately assigned with their what's it called, with their longitude, latitude, the phi, lambda, and the gravity values with respect to their height. So all these together, we're gonna tell us the procedure. What did you do? Okay, I first of all map those point out to see how spatially they are distributed within the southwest region. That is the map. Now interpret. Okay, I interpret that. Okay, it is clumsy around south, or maybe Ekiti. We have how many points within Ekiti? Did you get my point? That is the interpretation. Like how many points are within Ekiti? How many points is within Benin State? How many points is within Lagos? How many points? So that is interpretation. Did you get my point now? So that's about that. Then adopted and used. So each student is expected to do this assignment independently. So based on the voice notes, everybody can just you can use that as a basis, and you can lay more foundation on everything, and then you prepare more accurate report. So, and then no group work is allowed in this case. So no group work. I'm just trying to explain what you're trying to achieve, and then there's something in A4 typed and spread bound copies latest 13th of February, and today is our 5th. So we still have like maybe a week latest, maybe 5 or 7 days. 7 days, no, 8 or 7 days. So good luck. So now let's move on to the analysis processing. So yeah, welcome back. So now this is what we have as downloaded from the group page. Let me open that. So the first thing you do here is you convert this XLS to your CSV. If you're using ArcGIS Pro, you can decide not to convert anything, but based on the fact we're using ArcMap, we have to convert it back to the format recognized. Did you get my point? In our you can see that around 302 stations. The headings make it to the one, so it's 302 stations. So you can see that we have the stations. The station are the 0.1, 0.2, whatever, and then this corresponds the lambda. This is lambda. Lambda corresponds to the longitude, and then phi corresponds to the latitude, and then we have the height, that is the elevation of those points. Don't mind me, I'm using a cracked version of Excel, Microsoft Offices. So this is my height, This is my gravity. This is the gravity value. So after it has been corrected, free here, this is the value for the free here, and this is the value for the bulgar. Did you get that now? So the question now is that we are going to map out this, we interpret, and then we perform modeling, analysis, and we are going to transect. The transect in the sense that we can just say, okay, right, I can draw a line in my arc map and interpolate those points and see what is the like, for instance, now this is an example of what I'm saying. Let's say station 1, I have okay, let's say point 1 to 10 the x and y. I already get the x and y in my arc map, and then I have the I want to use it based on free here. So you just come to your data, your graph, and just come to your graph, insert your graph and trend, chart. It depends on your choice. You can decide to use this. Did you see that? The free here being negative, you can use this type of chart, and then you can also decide to use normal line, something like this. Did you see that? You can decide to use something like this. Did you see that? You can decide to use something like this, depending on your choice, and then you can decide to use something like this. So depending on your choice, so it's a decision. But I'm not going to tell you which one I'm going to use. So, but you understand all this stuff. Now, the transit, it will be in form of a line. You know, on that line you have intervals 0, 10, 20, 30, 40. You're going to get points. There's a tool to calculate that thing, to calculate that station's interval in HackMap. Did you get my point? So with that, you'll be able to have the predicted gravity, the predicted bulgar, the predicted EF free, the predicted height based on the interpolation you've done along that transect line you've drawn across those states all together now. So that is all about that. Now, so based on what I was saying, you can see the format is in XLXX. So you need to convert this to my CSV. So you come back here and save as. Then you browse to location. You can see. So you just come here, save type as CSV comma delimited. So once you have it this way, then you're gonna see something like that here. I already done mine. That's what I have here. So you can see. Oh, sorry, I did it. Where is it? Okay, now good. This is my own CSV. Okay, let me just go in here. So you can see I've already saved it as CSV, so that's why I'm having it this way here. So that's my JS folder here. So I don't have to save it again since I have that already. Now back to our HackMap. But if you are using ArcGIS Pro, you don't need to convert to CSV. You can bring in your XLSX straight away to your ArcGIS Pro environment. But for this tutorial, we'll be using HackMap because mostly everyone is familiar with that. And then if you are good with QGIS, you can decide to go ahead with that. But as for me, I'm good with HackMap. So now, you go to your file. Once you open your ArcGIS interface, you go to your file, you add your data. What type of data are you adding? I'm adding XY data. Did you get that? So you navigate to that folder. Desktop. Did you see that? So you add a CSV file. Now, like I said the other time, your X corresponds to your X corresponds to your lambda, and then your Y corresponds to your phi. Then neglect the Z field because we have multi-column for that Z. So we are going to display that with respect to Z as far as we have our point. So the attribute of those points will be stored in the attribute of those points will be stored in in the attribute table of that feature layer. Did you get my point? So you don't need to disturb yourself. And then since it's in geographical coordinate system, specify the geographical coordinate system for that, which is WGS1984. If you don't have that WGS1984, come to your geographical word. You see that? So in case, you can right click, add to favorite. It's not active because I have it under my favorite already. So in case you don't have the WGS94, so that's how you can recover that as fast as possible. So that is all. So once you click on that WGS84, you have it there. So then you click OK. So you can see I have it WGS84, and then you click OK. So it asks you, do you want to add it out? Then say OK. So you have those points displayed on the map. So this is still working out. Yeah, good. So these are the points of the, what's it called? These are the points of observation. So now the next thing we're going to do here is that, you know, these are the points. So if you check, I don't know, have I export this out to my shapefile? No, I don't have it. So let me just quickly do that. Now, you know, this is Excel displaying points. So you need to export this out. You need to export this out in form of a shapefile. So you just see gravity stage, the gravity data. So you save that. And then you just click OK. So if you actually want to add this to the map, you say yes. So you see that? So we have it in shapefile. So you just check the shapefile, open the attribute table, and then you see that. So we have the points. This corresponds to my lambda. This corresponds to my phi. This is the height. This is the gravity value itself. This is the free air correction of the gravity value. This Boga gravity value and stuff like that. So this is the raw gravity value. So we are going to map this, and these out. Did you get my points now? So we'll be able to see where we have high gravity value and stuff like that. So I'm going to show you a lot of things you can perform as related to these tags. So you can see other fields are empty, so you neglect other zones, and just close this out, and then we can remove this. You don't need this anymore. So this is the gravity data. I'm coming. So, I'm sorry, I'm back. The assignment given to us by Professor Ojigi. So now the assignment is that we want to, please, we can meet ourselves. Please, we can meet ourselves, please. So we want to carry out like spatial gravity mapping and analysis from the given data we have. So based on the stations, we have 302 stations over the southwest of Nigeria and their corresponding heights, the free air and the Boga anomaly. So we have 4 parameters. We have the height, the gravity value itself, the free air correction value, and the Boga correction value of the gravity assigned to each point altogether. So now you'll be imagining, how do I get all this data? So I would like to like give us a brief explanation of how I got this data in here. So what we did was, as you know that we are given the gravity data in Excel file, XLXX. So what you're going to do here is you download this particular Excel file, you click on the download icon. Once you have it, you have it in here. This is what we have here. So you have the gravity data downloaded, and the next thing now is you open that in your Excel. This is what I have in my Excel altogether. So once you open it up, now I want to display this Excel file in my HackMap environment. Some people can decide to make use of their QGIS environment and more like that. So, but for this, I'll be using HackMap. So now, how do you go ahead with this? This your lambda correspond to your longitude, and this your phi correspond to your latitude altogether. Hello?
We are together. We are together.
Okay, boss. Now we have the height, the elevation assigned to each point. Point 1 is the elevation. The gravity in milligauss for this point, this is it. after the correction, the free air correction, this is the value for the gravity, and then the Borga correction, this is the value for the gravity. Now, we have 302 stations as sent by Baba. Now, what we want to do now is we want to map and interpret all these data out. And then I'll be making it a back map. Now, another thing is that they said you have to map, interpret this, and blah blah blah. The spatial analysis. So we are going to consider, for my own assignment, I'm going to consider a lot of spatial analysis. Some people can perform IDW, some people can perform hotspots, some people can perform zonal statistics. Did you get my point? So there are a lot of analysis you can perform regarding this data all together. Now, so what I'm going to do now is I'll be using two out of those analyses you're going to work with. So the more research you have, the more analysis you're going to come up with altogether. Now, how do I get this data here? We already have the Excel file as sent to us. Now, the first thing you do here is you convert. You can see the format for this Excel is XLXX. So you convert this XLXX to CSV. How do you do that? You go to your save as and then you convert that to your CSV file. You can see that I already have it saved as my CSV. If you just check your CSV command delimited here. Now, sorry. Now, here it is. This is the CSV file. I have it saved as CSV, so I don't need to bother myself maybe resaving this and whatever like that. So once you save it as CSV, then you come back to my ArcMap environment, and then you click on your file, you add your data, add your XY data, then you check the folder. This is the CSV file. Did you see that? And then you add up. So now your X feed corresponds to that particular lambda, but the lambda is not the symbol for that is not recognized here. So the column is I and F. The I represents the lambda, and then the F represents the phi. So this corresponds to my longitude, which corresponds to my X feed, and then this corresponds to my latitude F, which is the phi field, and then it corresponds to my Y. So the Z component, neglect this for the time being, because we have many Z we are going to consider. Did you get my point? We have Z in terms of height, Z in terms of ordinary gravity, Z in terms of the free air correction, and then Z in terms of the Borga correction, all together. So you neglect that for the time being, and then on your side you might not have this at first. So what you do is you specify the coordinate system for that. Since the coordinate system is a geographical coordinate system, do you get my it is the unit decimal degrees. So we already know that it is in WGS 984. So now you search for that. You can do that on your side. If you don't have it, come to your geographical and click on the word, and then you will see WGS 984. So you see WGS 984. Then once you click on the WGS 984, then you click OK. So it will automatically recognize this as the coordinate system by default. Then you click OK. Once you click OK, it asks you want to do this. Okay. Now you have this point in here as XY from your Excel. Did you get my point? You can see. Let me up this. You can see all those points. These are the points distributed throughout the entire the southwest area of the Nigeria, the zones. Now, the next thing you want to do is you are going to create a layer from this CSV file. You want to create a shape file from this CSV file. So you right click there, you go to your data, and then you export the data. So you navigate to the folder we are working with. You can see I have it already, the gravity data.shp. I already saved it. That's what I have here. So once you do that, just rename it to whatever name you want it to be. Maybe gravity SW data or data of gravity, whatever. So it's a choice. So once you do that, you save it, and then once you save it, let me just use a particular whatever. I'll delete it later. Then you save it, and it will ask you, did you want to export this to your map? They say yes. So you can see I have it here. So in case you are using the normal what's it called, the words, the gravity data, you can just add that up, and then you have it here too. So you can remove the Excel file you use, and then I don't need it since I have the shape file already here. So that's how you bring in your Excel file into your ArcMap. Now, the mapping tags, I can't just present these and say these are the,
Sorry, please.
yeah, go
Please
ahead.
go back small. Like how you extract the data. Like when you save your shape file. I beg.
Okay, how I
Just
save my shapefile. Okay,
after
okay,
you have added the CVS.
okay. Now,
Mm.
did you get this now? This is the CSV. Are we together?
Yes, yes,
Yeah,
yes.
Benga. Now, so if you want to export this CSV data into your shapefile altogether, you right click this particular feature layer, you go to your data altogether.
Yes, yes, yes.
Now, you click on export data. So you navigate to the folder where you save your data. Did you see that? What I save now is there. And then you write the name of your choice, maybe Southwest Gravity Data. Are we together?
Yes, yes.
Yeah. So once you do that, you save that, you save that up, and then you click OK. It will ask you, do you want to add this exported data to your map as a layer? You say yes. You can see that I have it now. Did you get that?
Yeah, yeah. Thank
So
you.
yeah, you're welcome. So you can just try to remove that or so I don't need all those ones. Now let's assume this is a new shapefile I just imported into my ArcMap. Now we have it displayed on the map. Now I want to map this out. How do I map this? I can't just present this out and say this is gravity station. It doesn't sound like I don't know what I get my point. It doesn't look like like you working as a cartographer or geospatial analyst. You can't just present. Anybody can just say these are just points. Then how do you now map these type of things out to visualize or the parameters one after the other? Now, if you see this layer, in our Excel the other time, we have the information about those stations. We still have them. If you check your attribute table, you can see all those information are still there, right? Just that your height corresponds to your lambda, your f corresponds to your phi, and then the height, the gravity in milligar, the free air correction, the Boga correction, and then the other phase are you can neglect all this other part. Are we together now? Hello? Are we on the same page?
Yes, yes,
All right.
yes.
Okay. Thank you, Benga. Now, after you're done with this, now we already bring our database into the ArcMap using the geolocations to to relate those information pertaining to their original station. Now, what we are going to do next is we check the question again. Now, we just inserted we are going to write the report on the software platform and the procedure adopted used. Did you get my points now?
Yeah, sure.
I'm already telling us the procedure of how we are carrying out the task now. Did you get that? Now, the instruction now is that you have to map and interpret the gravity. You see that? The gravity, this is the gravity. This is the gravity. Did you see that? This is the column for the gravity. Did you get that? We have to map this one. The next, height. This is the column for the height. And the others. The what's it called? The free air and the burger as I've shown you the other time. So now, what you're going to do here is now, how do you map? Now we just pinpoint all this on the map. Now, but this is not yet a map. Now, what we are going to do, the first thing we are going to do, the map we are going to present to my own understanding is the spatial distribution of gravity data within the southwest region. Now, how do I do that? I can't just assume that I'm in Nigeria already. You have to bring in a shapefile, maybe a boundary data of the entire country. I don't know whether you get my point. So how do you do that? I for those that are coming to our tutorial, I sent a working folder the other time consisting of the Nigeria data set I've been working with so far. So you can just try to to get that, and then you see your Nigerian data there, and you can add it as a layer, as a feature layer in our ArcMap. So that is my D survey files. So this is the Nigerian data area. So I'm going to use the OSM Nigeria boundary data. Did you get my point? Now you can see the Nigeria admin 0, Nigeria admin 1, Nigeria admin 2. Your Nigeria admin 2 is pertaining to local government. Your 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 Nigerian admin. I'm using the OpenStreetMap Nigeria boundary. Did you get my point? So if you want to, you can bring in your boundary in now, and as you can see, I have Nigerian boundary admin 0, which is the entire Nigeria. Let me just bring it in so that we can understand what it's all about. So I won't be using mouth to say bring it in. So now you see that this is for the Nigerian. So we want to start our mapping now. So, but the first thing we have to understand is what is the spatial distribution of all these. You can see that is the states. Did you see that? So for me, at least I'm still good to this level, the state level. I'm good to the state level. Some people can work with respect to the third tier level, like you can work with respect to the local government. That is, you want to break it down to the lowest unit in the southwest. You get my point. So some people can still come down and decide to add up the local government data. Did you get that? You see, this one is very much, and so we can see some local government in here. Let me try to add the labels for the local government so that we can understand what I'm trying to say. So, but for me, I think at the state level, I'm still good, so that I won't just be working extra mile for my life and stuff like that. So you can see that we have like eight, what's it, 80 circle west. We have like 1 2 3 4 5 6 7. So we are already interpreting this data. So we have how many stations within this local government? We have how many stations within this local government? How many stations within this local government? I don't know whether I get my point now.
Yeah, we understand.
Yeah, so like that, like that, like that. How many ones do we have in Lagos? We have let me off this first. Let me just see. Okay, now this is the entire Lagos. We just have how many stations? We have 4. 1 2 3 4. Did you get my point? So we are interpreting those stations already. So that means some areas in Lagos are still lacking those gravity values. So in Ekpe now, we didn't have anything in Ekpe. Did you get my point now? So that is uh, that is up to you to decide which tiers or which level do you want to use for your mapping altogether. But for me, I'm going to use states. Don't mind me, I can use local government if I change my mind, though, but I'm just trying to explain to you using the states shapefile. Now, this is the state shapefile. Now, we need to produce a map first. Then, this is the states. You can rename that to your states. If you have any question, you can come up. This is the states. This is the local government. This is the local government, and this is the Nigerian shapefile itself. So now I have those included in my map now. So now, how do I map this now? So you can decide to use any color symbolization. When you are trying to map, you can use any symbology. Did you get my point? Something related to of your choice, something of your choice, and then you can just try to let me use, not to make it the same things. Let me use this. Did you get that now? So this is my own. You can see we have one here in so that state is lacking more gravity. What's it called? Gravity data or gravity value. Add me one. So click OK. So Taraba, we are lacking all those. We are lacking many stations in Taraba based on the data given to us. And then now we can see Niger State. We have more data there and everything like that. So now this is spatial distribution of gravity. This is the first map we're going to produce. The spatial distribution of Did you get that? So this is one of the first map we are going to produce out, because we have to understand how spatially this gravity station are distributed first before you now start performing our analysis, maybe spatial interpolation or whatever like that. So that's the first thing to do. So next line, I want to bring in the next line inside the margin. So you can select your choice. Let me use this. You can select the choice. So that's my border line. So I can bring in my grid. let me use the gratical, and then let me use tick. Did you see that? Hello, are we together? You gone?
Yes, we're together.
All right, thank you.
Yes,
Now,
yes, you're with you.
okay, sir. Thank you, sir. So it's 12. Okay, okay. Okay, I'm still okay with this. Then let me try to let. You can use different layouts. Do you get my points? You can decide to use a portrait, landscape, whatever of your choice. You can decide that. This is just like an example first. This is why this is 4. Okay, good. Still good this way. Yeah. I'm trying to ensure that the labeling of the coordinates, the geographical coordinate system are okay to some extent. So that's what I'm trying to achieve. Now, let me insert my title. So all these things are what you know. So I'm just trying to start from the scratch so that we all understand what we're trying to do. Because I can just move on to the analysis straight away. So this is
I think you should move to the analysis. BJ.
okay. Now
Mm.
you can all do this on your own. So
Yeah, it's better you go to the next one, please.
okay,
Thank you.
You're welcome. Now let's go back to now. We have many spatial analysis we can perform. Now we want to perform spatial interpolation altogether. Now, how do you do that? You can search for that. Some people can use gridging, some people can use natural neighbors, some people can use let me just search for IDW. So you see many tools you can use as regards that. Performing the spatial interpolation. Let me just go to the toolbox itself. So now you see you can use IDW, you can use gridging, you can use natural neighbor, you can use spline, blah blah blah. But this 1, 2, 3 is the most commonly used spatial interpolation. So I prefer using this. So what I'm going to do now is sorry, my system is still loading. Sorry. Let me just pause it. Like the interpretation.
Mọ nǹkan tí mò ń sọ. BJ mọ nǹkan tí mò ń sọ.
So back to our interpretation now. Now,
All
if I
right.
search for the tool IDW, we can use any form of spatial interpolation tool. This is where you can find them. You go to your raster interpolation there. Just use any one of your choice in there. But I prefer using this IDW. You can use gridging, you can use natural neighbor. So depending on your choice. So I'll just pick my gravity data. This time it's a con. Share that.
Bóyá ká pàdé ní campus òkú gbé project wà ká mú jọ́ kankan fi wá ṣe sàmì gbogbo wa. Wàláì. Wàláì.
Tó bá ti wá ó máa record ẹ̀ sẹ́
My recorder, so people will okay, right, good. Now,
Ma record it.
like based on the assignment, we are asked to work with four parameters. The first is the height, the second is the gravity, the third free air and the booger. So now, the z component in this case now will be my height first. Are we together? Good. Now, you check in for your environment. The environment will be the raster analysis will cover the entire what's it called, the states. I just need it within the states. So you're gonna see the result very soon. So just click OK and then let's have the result.
Sọ̀rọ̀ online ló wà, Adébọ́lá sọ̀rọ̀ online ló wà.
You can talk. Oh.
I do not understand.
Where did you
Ó pẹ́ dé náà, ó pẹ́ dé.
Okay, give me okay.
Báwo ni máa bọ̀ lémi wá kọ́ ẹ? Máa bọ̀ lémi wá kọ́ ẹ. I have been do special data.
Bola no will understand.
GIS part ni
You
mi.
can see this,
Ni mo
right?
bẹ ti débi náà.
Awesome. What's it got to sọ yín?
Yeah.
Today.
So this is the estate of the area coverage.
Kò ṣe bí.
So we can symbolize this. I can use stretch value. Let me just use stretch value. The gravity, let me use range of red, okay, red, blue, and whatever like that. So did you see that? Let me invert this. Invert. So now, where you have all those red areas all together, the red zones shows that your gravity heat is high all together.
Yes.
Now, for the area where we have pink color, whatever like that, so it means the gravity is somehow that low, and the blue is moderately, the green is moderate, and the red is where we have it to be high, very high. Now, the interpretation of this is that I want to interpret this map now. Now, based on the states, let me label this. Now, based on the states, you can interpret which state has the highest gravity value. Are we together? That is the interpretation. So there must be a reason for that to happen. Why the state is having what's it called?
Yeah.
The highest gravity value. Are we together now? So now we can see federal capital of the Abuja, Niger state is we are having some the southeast of Niger state. We are having some reddish zones which signify that it's very high within this area. So now the interpretation of the data now is that you can use what's it called, zonal statistics to interpret this data. How do you do that? This is how you do it. Statistics. We want to calculate what is the average gravity value in that state, what is the average, the minimum, and the maximum. Are we together? So that is what this is going to give us. Statistics. That's a table. Yeah. Now, you can notice that we don't have those points along this voucher and whatever, but based on the fact that we have some points within this area and some points within this area, so it's help us to interpolate new zones in Kaduna, because we don't have enough points here in Kaduna, we don't have enough points here in Bauchi. So the IDW is that it will inverse distance weight. It's going to use how close those points are to determine what is likely to be the value of the gravity within that state. So now the function of this zonal statistics table, it will help us to determine what is the minimum, what is the average, and blah 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 of each state altogether based on this data. So now I'm going to insert the raster. Wait. Where is that raster? Try to export that out. to the control. Why do we have this? Hello, are we together? Are we there? Joshua, are you there?
Yes, you are here.
Okay. Joshua, do you have any idea on that? I'm trying to perform statistics, general statistics.
Yeah, mo get.
Well, you could read raster me now.
Nǹkan tí ò jẹ́ kó rí
Yeah.
ṣebí minimum value for each kini ni àbí each state.
Yeah, I want to use statistics tool to calculate what is the average, the minimum, and the maximum for each state. Normally, where you could read there. I don't know what is happening. Okay, sorry. I'm the one making the mistake. Sorry. The first one is the boundary. Did you get my point? The first one is the boundary, and then the zone. Yeah, that's the admin name. The admin name will be the state, and then this is where I will input my raster. I'm the one making the mistake. Sorry, I thought the raster first. I'm sorry for that. Did you get that now? Are we all together? So the first one is to import my zone, that is the boundary, the area of our interest, which is the state, the interest state. You can use your local government if you want. You get my point? Some people can use to the level of local government, some people can use to the level of states. And if you have your ward, you can use that too. So now the zone field now will be the admin name. The admin name one corresponds to the name of the states in Nigeria, and then you will now import your value raster, which is the IDW of the gravity. No, the first one we did was height, right?
Yes.
The first one we did is height, not yet gravity.
Yes.
So you have to be very careful about that. So the first one we did was height. So now we'll be able to calculate what's the minimum height, what's the maximum height, and blah 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 like that. So we're able to do that. Now the statistics type, I'm going to choose all. So that I can have every information pertaining to any statistical measure. I can have everything. So once I click all, and then click OK. So the result I'm going to have will be in the form of a table. So you cannot arrange that table. That is the interpretation. You get my point? Now I will show you now. This is the table, zonal statistics shapefile 9. Now open this attribute table. You see what I'm trying to say? Let me make it big. Now see this. You can see the admin name, Anambra. Did you get that? Bauchi, Benue, Cross River, Delta, Ebonyi, blah 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 to Zamfara. We have 26 states having all these values based on the points we got from the lecturer. Now, what is the area? Okay, no, this or this. What is the minimum height? Are we together? The minimum height in Anambra is this. The minimum height in blah 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 is this. The maximum height is this. The range is this. The mean, the average height there is this. And then the standard deviation is that. So it's just about what I need here is just like the minimum and the maximum and the average. So that's all I need. Minimum, maximum, and the mean. So you can plot a chart. You can plot a chart in your Excel using your, let me see, I can do that here. Create a graph, yeah. So vertical bar, the legend is, yeah, you need this. So the value should be value fit should be maybe minimum. Did you get my points now? Hello, are we together?
Yeah, we are together.
Yeah.
Yes.
So minimum in ascending. No. Minimum admin name. Ascending order. Name. Did you see that? That is the interpretation of the data. Did you see that?
Yes.
So, next, now we 3D. This below. Did you see that? So this is the gravity. You can see what is the minimum height at Anambra is around 100 or something. Did you get that? What is the minimum height at, like the color shows? You can see that. If I extend it out, I'm gonna have. Did you get what I'm trying to say now? This is the interpretation.
Sure.
So this is the interpretation of the data. So Anambra, this is the height. So like that, you can see. So which one has the highest height? I'm having Ekiti. Ekiti is having the highest height here.
Ekiti.
Yeah, Ekiti is having the highest height now. So you can see that now. So it has the highest height. So based on the height, based on what we are taught, the greater the height, the lesser the gravity value. Are we together? based on the theoretical class we have with Professor Ojigi, if you have your height to be, if you have your height to be like, if you have higher elevation, the
Yeah.
value of the
It's
gravity
better
there
the
will be very
gravity.
low.
Yeah.
Yeah, did you get my point now? So from this interpretation itself, we know that okay, the value for Ekiti, the gravity value for Ekiti must be low compared to where we have in Ondo here or in
Edo.
Edo. Do you get my points now? Good. So you get that now. So that's the interpretation of those data. So let me just try to, yeah. So that's the interpretation of the data. Now the mapping now is that, now based on what I did the other time, that I tried to come here and now you can map out the minimum. How do you do that? You can map out the minimum. How do you do that? Zonal statistics table. I want to map the minimum. There's a way I can do that. There's a way I can do that. I have it the area. There's a way you can map these out. I've forgotten. There was a, and I just taught someone recently. What I'm trying to do is that I want to show us, like, this is an example of what I'm trying to say. It's not here. I didn't download it yet. It's a map. Like, the map will be showing us the average, what is the average height at this, and what is the highest height. So I'm going to have those maps in form of I'm going to have it in form of a map. The information I extracted from this, I'm going to have it in form of a map. But I've forgotten how this guy did it. Okay, is it now IDW? Yep, I think they use IDW. Let me use that. I'll just specify the table. No. There's a particular thing it did. I've forgotten. I will pass that across later. But you can transfer this. What's it called? I'm coming. I use zonal statistics as a table. Let me use the ordinary zonal statistics. I think that should work out. Yeah, let me use this. Let me import the raster. This is the area of interest, the country name, nope, the admin one name, and then the value of the raster to be IDW days, and then I need it to, okay, now I think this is it now. So I'm going to have what is the mean, what is the mean, what is the maximum, and what is the minimum. What is the mean, what is the mean, what is the maximum, and what is the mean, maximum, and the minimum, the range, the sum, and blah blah blah. So let me just use the mean. So I want to calculate the mean now. So let me just do that first, so we can see I got what I need. The zonal statistics as a table, that is for your graph. All together, use that for your graph representation. Now the zonal statistics ordinarily is, that one is in form of a map. You will see it's going to display on the map now. Did you see this now? Hello? So this is, we are able to see that the elevation, so you're going to use the elevation ramp. So we are having more elevation.
DJ, is this all for mean?
Eh? Yeah, this is for mean. Did you get that now? So you're going to prepare a lot of map. So you can see this is the mean. This is the average height. No, this is the minimum height. Which state has the minimum height? The highest. I don't know what I get my point. This is what I'm trying to say. Let me open the table. Yeah, this is it. What I just visualize now is this data here. I just visualize this data. The minimum height. Did you get my point? The maximum height. Did you get my point?
Yeah.
And then the mean and blah 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 like that. So you are going to repeat the same thing for all those parameters. All together. So you are going to repeat the same thing for your what's it called? We have a lot of things to do. We are going to present a lot of maps. We are going to do the same thing for the gravity itself, the Bogwa, and the free air. So it's 4. height,
Uh,
gravity,
and we are
Boga.
going to do mean everything for the 4.
Yeah,
Mean, my
the min
minimum.
map, the maximum map. It depends on your choice. It depends on your choice. You know, it said map and interpret. Do you know what I mean? For me, I'm going to do everything all together.
I will do everything too.
So good. So I'm going to do the same thing for the graph too, the charts and everything like that. So I'm going to interpret in terms of minimum value, the maximum, the mean, using the tools I use in ArcMap. You know, it was stated that we should list the procedure of how we did it based on the software we use. Now, so I think that is all for that. We all understand that one, right? Are we together? We all understand that? Hello?
Yes.
All right, good.
Yes.
Now let me move on to the next question now. So we're able to do, we're able to analyze the gravity, which one is the state with the lowest, the state. You can use your local government too. Did you get my point? Are we together? Instead of the
Yeah.
state level, you can bring your own to the local government level. But as for me, I can go to that local government level because I know it's like to the smallest unit part. Because if you are taking state, the professor will say you are very lazy. Do you get my point now? So you have to take things that are very
We should
obvious.
just go down to the local government.
You get it now.
So that one will be a lot of analysis.
And now, you get my point now. You get my point now. So now, the next is the modeling. How do you model? We just model one. We model all those things in form of a map. You get my point now. We model one in form of a map. You can also do 3D modeling. All together of any one of your choice. You can do 3D modeling, but it's possible I do a lot of 3D modeling for everything. So now, how do you now do the modeling? That's where I'm going now. This is the zonal statistics for minimum height. So this is minimum height. Minimum height. This is the minimum height map. This is the minimum height map. So you just go to your these and specify whatever like that. So you'll be able to see, okay, which state has the minimum height. So like that. Then which one has the maximum? What is the average distribution? What is the just you are trying to observe all those things statistically. What is the mean? What is the average? What is the mode? You get my point? What is the whatever like that. So depending on your choice, you can deal with maximum. Some people can take minimum depending on how, the time frame you have on your side. So now let's move on to the next question. The modeling, yeah, we model in 2D right now. That's the modeling part. We just model in 2D, and now you can also decide to model in 3D altogether. So the 3D part is like this. You just perform something called shade. This is what you're going to do for no space, sorry. So you're going to perform the E-shade. Now, bring in the raster file. This is the raster for my height. I'll together now. So now, sometimes people change azimuth and altitude, and as you can see here, it's optional, so you can decide to change or not. But I always leave everything by default. Now, this Z component, it varies. This is just like you're trying to, now the unit of the output geographical spectrum are undefined. Okay. So we are using 1. The information was like the Z unit of the blah 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 are undefined, so the default Z factor of 1 was used just to tell us that okay, default factor of 1 was used, and that is the normal thing. X1, Y1, Z1. That is the normal plane as we can see. Now, but if you want to exaggerate, your height, but it must be stated in your report that for us to see the 3D representation of that area based on the anomaly, the free anomaly or the Bogo anomaly, I exaggerate the height by maybe by 2, by 3, by 4. Did you get my point now? So but let me use 1 first so that I can see what I'm trying to say. Let me use 1 first. So that is 1. Did you see this? Hello?
Yeah, we are seeing it. Yeah.
Yeah. So this is the 1 vertical exaggeration. Now let's try maybe like 4. Let's try 4 exaggeration. Let's see the difference. So it's going to project the background. So, but it must be stated in your report for you to visualize more very well. I exaggerate my vertical whatever to 4. So you'll be able to see the depiction of those terrain very well when you exaggerate. I don't think there is not much difference here. But assuming it's in what's it called, infraworks. When you perform exaggeration in infraworks, it seems it looks good. Like when you exaggerate by 1, that is the normal flat surface as if you are standing on that surface or observing the ground. That is 1. Z is 1. When you say Z is 2, it will multiply the height by 2. So you'll be able to see like, oh, this place is very high and blah 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 like that. So stuff like that. So that's what exaggeration is all about. But looking at this, I don't think that is effective. So you can just leave
It's
it.
still the same. It's still the same.
Yeah, so it's still the same. Yeah, it's not effective here. It's not effective. It's not effective. So let's leave it to 1. So let's leave it to 1. Let's leave it to 1. So that is the vertical gyration in 3D form. So but I can advise us to use software for that. Did you get my point? Hello? Are we together?
That's if you can use
Yeah,
software.
we can use software. We can use accent. But looking at this way is going to bring in an accent too. But software is going to like show you the 3D, like the contour. You can also prepare contours too. You can prepare your contour maps because it's like X, Y, Z. So the Z will now vary based on the parameter. So you'll be able to see where the gravity value converges to and blah 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 like that. So like that, then we can map out and interpret for each state. Now, another question I have here is, we are done with the data spatial analysis modeling. Now, transect analysis. You see this transect? It's very simple. You're going to draw a line. Transect is just like you're drawing a line across different states. Like you're going to draw a shape, maybe shape far from Oyo. You can draw the line. Let me just do one. I want to do one. Check the coordinate system. Okay. Now I have the line. Just start your editor. Your transect is just like you are having a line. Just now see this. You see transect layer selection. This transect is for hydrological analysis. Are we together? For shoreline detection. You can see the transect layer. Transect is just like a line. You draw a line. It can be a curve. It can be a straight line. It can be of any line. So once you draw the line, you now get the value of each parameter at equal interval of your choice. Are we together? For instance, that let me do that. Let me do so that you can understand. Now, I want to draw a line maybe from Niger State passing through Oyo and going to Edo. Are we together?
Yes.
So that's the line. That's the line. This is my transect line. So I want to see, like in form of a profile. So I want to see what is the gravity value. How does it varies from Niger State, passing through Oyo, and then stopping at Edo at a particular interval. I did something related to this with Sophia Wasil the last time. He wants to do offset, like trying to do creating point at offset. Can you remember the tools we used then, Wasil? So Wasil, are you there?
No. That goes low.
What's that? I used one point at a time. I point at interval. Wait. Point. Just wanna go in. Go save me. I want to cancel the meeting.
I cancel.
Cancel. Point along. Just give me the line. Just give me generate points. This is the generate points along the line. Choose. That's it. Generate points. It's not create points. Generate. There are a lot of tools in this Zark map. Yeah, here it is. Generate points along lines. So you now specify the line. So these are transects. Just like you are bisecting something with a line, and you now observe that line. I don't know whether I've seen a geological map before. There's something called fault line. It's not for a straight line. So the line will just pass across your region, like your study area, and then you check the like it can be in terms of elevation, it can be in terms of gravity, it can be in terms of any parameter you're working with. So use meter. So or maybe kilometer because the area is very far. So I will now use maybe at every 1 kilometer altogether, that's 1,000 meters. So it's going to generate point for me altogether. It is hello.
I mean, we do 100.
All right, thank you, boss. Now you can see it's going to extract the point. Joshua Salam. Josh.
Make a check.
Motion wa mo ń dáná lọ́wọ́ ni mo ṣe ń fetí kan gbọ́ ọ̀nà mọ́.
Okay.
Now,
can you see the points? Can you see the points at 1 kilometer? Did you see that?
Sure.
Now, so that is the transect. A line, you draw a line, then it passes through your study area, then you extract information about the points along that line, and then now how do you now extract the height value? You see, whatever you are doing to height, you're going to apply it to your, what's it called? You're going to apply it to your gravity, Bogwa, and air anomaly. Are we together? Free air and the Bogwa. You're going to, whatever you do to height must apply to every other things too. Are we together? So now that's how you can do that one. And then how do you now extract the information? Let's say add surface information. Add surface information. Yeah. This is it. So you have to tell us the steps you are taking for everything, the tools you use, everything like that. So you have to import the point. You know, this point is different from the one we did. Someone can take the transect from, you can take the transect from maybe Lagos to Ekiti. Somebody can take the transect from Edo to Niger. Somebody can take the transect from Niger to Ibadan or maybe Oyo State and whatever like that. So that's how it works. So then you insert the surface. Now, you know the surface we created the other time. The surface we created the other time is IDW, that is for the height. Then you just check the Z and then you click OK. So my own is passing from Niger to Oyo and Oyo to Ondo. It's stopping in Ondo. So now, right click and open the attribute table. You can see that is the elevation value. You can see the elevation now. So that's the elevation value for the transect point we did. So that's all about whatever you want to achieve, and then you just try to let us know about the methods and the software you use and blah 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 like that. So that's everything you want to do. So and then you follow these other instructions and then you are good to go all together. So any questions?
Question.
Okay, sir.
The last aspect here, I don't understand very well, but with time, I know I will get it. But that's the only issue for now.
Okay, anybody else?
No question, BJ. Thank you.
All right, you're welcome. You're welcome. So I'll upload the video, then you can all check that. So thanks so much. Bye bye.
All right, thank you.
Yeah, bye bye.